the expanding science of brain stimulation, from treating illness to optimizing human potential. A basketball player wants to shave half a second off reaction time. A weightlifter wants to push through mental fatigue when it counts most. They are both considering the same intervention, sticking electrodes on their scalp and running a low electrical current through their brain. Does it actually work? And what does it tell us about the brain circuits that govern motivation, focus, and human performance? Transcranial direct current stimulation, tDCS, delivers a weak constant electrical current through electrodes placed on the scalp. The anode electrode goes over the target brain region. The current flows beneath the skull to the cathode. It does not directly trigger action potentials. Instead, it shifts the resting membrane potential of neurons, making them slightly more likely to fire when they would normally fire anyway. Anodal stimulation increases cortical excitability. Think of it as turning the volume knob on a specific brain region. Not all the way up, just a nudge. A new systematic review and meta-analysis in BMC Psychology looked at anodal tDCS effects in athletes, 14 studies, 376 participants. Attentional performance improved with a Hedges G of 1.18. Cognitive function improved with G of 1.12. Mental fatigue dropped significantly. Reaction time improved with G of negative 1.35. On paper, these are not marginal gains. They are substantial. The mental fatigue finding is the most interesting. The prevailing explanation is cortical efficiency. tDCS may allow the brain to perform the same amount of work using fewer neural resources. When the brain is working less hard for the same output, subjective effort drops. The athlete does not feel as tired. The same mechanism, improved neural efficiency, is one of the hypothesized ways that antidepressant medications work. The circuit is the same. The clinical goal is different. The primary stimulation target across these athlete studies was the dorsolateral prefrontal cortex, the DLPFC. That is not a coincidence. The DLPFC handles working memory, attentional control, and executive function. It is also one of the most studied targets in depression neuromodulation. Transcranial magnetic stimulation targets the DLPFC for treatment-resistant depression. The same region, the same circuit, the same functions, divided by context. In depression, the DLPFC may be underactive. In a healthy athlete, the question is whether you can push it above its typical ceiling. One of the most counterintuitive findings is that tDCS does not improve athletic performance through muscular mechanisms. Cyclists who got anodal tDCS did not produce more leg power, but they reported lower ratings of perceived exertion. They felt like they were working less hard for the same output. The effect is central, not peripheral. This is consistent with the central governor model. The brain continuously models the body's state and decides when to slow down, based partly on perceived threat to homeostasis, not purely on metabolic accumulation. Here is the important caveat and the broader point combined. The performance effects on attention and fatigue were robust, but mood and motivation effects in athletes were inconsistent, not reliably improved by tDCS in the meta-analysis. The cognitive and attentional effects are more reproducible than the effective ones, yet the circuits that govern fatigue resistance, focus, and effort-based motivation are the same circuits that appear to malfunction in depression and anhedonia. The DLPFC, the prefrontal regulatory networks, they operate on a performance continuum. When they are disrupted, you get anhedonia, mental fatigue, the exhaustion that does not resolve with rest. The brain does not have separate systems for athletic performance and mental health. And what do we actually know? Anodal tDCS to the DLPFC produces small to moderate improvements in attention, cognitive function, and mental fatigue resistance in healthy athletes. We do not know how durable these effects are outside laboratory conditions, whether they transfer to actual competitive performance in a meaningful way, or whether long-term use in healthy individuals carries unknown risks. tDCS is not FDA-approved for any psychiatric indication. It remains investigational. But the neuroscience point is clear. The circuits we target when we treat depression are the same circuits that determine how well a healthy person performs under cognitive demand. The future of brain stimulation may not be either-or between treating illness and optimizing function. It may be both, through the same mechanisms, along the same continuum. Questions or episode ideas? Drop them below and subscribe for more psychopharmacology breakdowns. Educational purposes only, not a substitute for clinical judgment.